My name is Mark Kriegel, and today, please, this can be an interactive session. Please feel free to stop and ask questions at any time. I'm a regional sales manager at Hewlett Packard, but I want to start with a 4-minute video just to set the scene. So I'll just let these people come through, and I'll start the video.
As governments around the world are struggling to maintain basic citizen services, one European government, the region of Flanders in Belgium, takes a pioneering approach to e-government. Meet Flemish Government CIO Luc Chauvin. He's reinventing e-government and has guided the IT efforts central to achieving his administration's objectives to increase efficiency and reduce costs. Chauvin's team provides the IT infrastructure to handle individual student scholarships, farm subsidies, and everything in between. How does he do it? By enabling immediate and proactive service delivery through a common web services platform built on an HP service-oriented architecture, or SOA, a key component of HP's application transformation solution. The platform, known as Magda, enables the administration's guiding principle of once-only data collection. It's the core solution that drives Flanders towards becoming an instant-on government.
I think it's the new normal. There is no alternative. Instant on, anytime, any place, any channel, service delivery at an instant should be the way of working. We have two basic concepts in the Flemish administration. One is that we will never ever ask twice the same information from a citizen. The second thing is we need to make sure that the effort that the citizen is using to make the request is minimal.
The Flemish government is a model of how to reinvent e-government. Once only data collection has been written into law, and the proactive structure Chauvin envisions is moving the administration further down the path towards becoming instant-on.
Rethinking the whole chain of events towards a concept that if you are entitled to something as a citizen, you should not even ask for it. You should just receive it.
In the past, my mother had to run from one office to the next to get all the necessary paperwork done. But now, all I have to do is simply use my EID card and I can check if I will get a study grant. I received an email that confirms I'm getting a grant.
As with any instant-on enterprise, the Flemish government focuses on agility and speed, key benefits of HP's application transformation solution, and how the HP SOA-based Magda platform enables both. By using standardized building blocks, Chauvin speeds up service delivery. In choosing HP as his technology partner, he focused on HP's ability to help Flanders become an instant-on government.
HP is one of the main players in the world and in ICT. HP has the most coverage, let's say, of the different things that are important to us.
While other governments cut services for lack of funds, Flanders plans to add new ones.
So if you, both as a citizen or as an enterprise, if you want to construct a new building, there's a whole very complex procedure which has to be fulfilled. We are now trying or looking at how we can fully digitalize the whole process of obtaining a building permit.
Though he knows Flemish citizens expect fast, quality service, Chauvin recognizes that becoming an instant-on government is a process.
I think we are at the start of a journey. I think on the technology we are in a position that we can do what we want to do. The major challenge to be addressed is the working culture. The younger generation will not only see this as the normal way to work, they will actually demand to work in that way.
I hope you enjoyed that video. No matter how many times I see it, I do quite enjoy that one. And for me, that video shows how incredible the service you could perhaps achieve by empowering and enabling not just your staff, your citizens, but also the businesses in your local environment, your local economy, by giving them intelligent access to real-time information. You could really achieve a new level of service experience. But what is apparent from that video, and all the machine, the hardware there, was that was a major project, a major program, and that took time. And that takes a lot of time, and time is money, and it's time that a lot of us haven't got enough of. So what can be achieved in a short-term basis? What can be a quick win? What could HP bring to you today that maybe provides you with a platform to perhaps realise some of those benefits that that video talks about? What if you could seamlessly implement a database? A database that does provide real-time analysis, the ability to load information and query information at the same time, the ability to scale to petabytes, a platform that is future-proof for all your future requirements, no matter how far you scale. A database that can take feeds in from all your legacy database environments, making sure that you do get a return on the investment you've already made in your current environment. This is not a disruptive technology. A database which uses common industry standards, so things can be run at a fraction of the cost on a fraction of the hardware as previously envisaged. So I'd like to introduce you to HP Vertica. For those that weren't in the session earlier, this is part of the family of HP software. I'd like to talk to you a bit more about what is Vertica, give you some examples of how it is used, some of the use cases that we'd like to talk about, case studies, go into some of the technology detail of how it works. And after setting the scene on those bases, perhaps talk about how it might fit in your environment and what could be the way it could be applied in your organisation. And say, please stop at any time, questions, absolutely fine to do so. So what is Vertica? It's a new part of the family of HP data analytics software. It can perform queries about 50 to 1,000 times faster than traditional databases at a fraction of the cost. It is a relational database system, but unlike traditional ones, it's absolutely designed from the ground up to deal with the complex volumes and analytic workloads that we're now confronted with. So how are some companies and organizations using Vertica? So it was mentioned in the presentation earlier, but it's a great use case, very, very interesting situation with the Democratic National Committee in the recent presidential election. The committee had a mantra to measure everything. That was their absolute focus. So in trying to be ensuring the success of Obama to be re-elected, the mantra was measure everything. And they had to look at multiple databases and try and extract them all together and to give themselves that picture. So they had voter roll registration, previous donations registration systems. They have feedback from the volunteers that are phoning potential voters, emailing voters, telephoning voters. They took all of that kind of information along with social media feeds, and they worked out what was the best way to target their resources. So Vertica was the platform at the top. All these other databases were feeding in, and they were able to understand where the swing voters were, what their issues were, and really target the follow-up resources and information back to those swing voters. The other interesting thing they did was that they looked at television and radio advertising and where best to spend. You may be aware in the US they do spend a lot of money on elections, on frankly spending a lot of time slagging the opposition off, but it's certainly a big part of how they see their election campaign. And the interesting fact is that Obama had a 20% less budget to spend than Romney, the other guy. But because they had effective use of information on Vertica, they targeted the right people in the right areas with the right messages in the radio and TV campaigns, and Obama was successful. So I'd like to think that was down to Vertica. Obviously, I'm sure Obama would have a different view on that, but certainly the analytic tools that were used for the Obama campaign were not used by Romney. He did not embark on this path at all. So he certainly chose a successful one. Another use case for Vertica is a mobile phone gaming company called Zynga. I personally have no use cases myself. I don't personally play on my mobile phone on games, but it's a very, very popular pastime. You'll see many people doing this. And Zynga have now 40 million players registered with them. And these are online real-time games. So if you're not familiar with these types of games, they're players, they're playing with other people in the same game, in the same session at the same time. And obviously Zynga is trying to make money. So how do they do that? Well, first of all, they want to ensure that people play for as long as possible. So they constantly analyse the game and where people start to get bored and where people start to drop off. They also analyse who's following people in the game. People tend to group and they tend to follow certain people. And they then try and work out when to give people the opportunity to buy certain features, like a magic potion or some kind of fancy sword. And they decide what price level to offer that at. And that can depend on how much is that person an influencer on the other people in the game. And they're making all these decisions in a real-time fashion so they can keep people hanging on, playing the game for as long as possible. So Zynga now has over, I think it's actually 240 clusters now, analysing over 3 petabytes of information. They're ingesting terabytes of information on a daily basis, all being analysed in a real-time fashion. And the real key message from this slide that I want you to take away really is that they measure everything, in the sense that they measured every single click and they've stored every single click of every single player that has ever played on their games. And that's the power of statistics, really, is that the more data you keep, the better business decision or organisational decision you can make. Today, your organisations are making decisions based on perhaps 5, 10, 15% of the available data. You have an opportunity with this kind of technology to take in all of the data you have today and all sorts of new streams of data from external sources, social media, internet, whatever it might be. So you have the ability to make a better business or organisational decision. Another use case for Vertica has been in the pharmaceutical research and development type environments. This essentially is a very simple one. When you're researching and you're trying to find answers from data, you're trying to search for a new drug, obviously there could be huge amounts of data involved, and in Novartis were experiencing query times of 4 or 5 hours before they were able to get to the next stage. Using Vertica, that was reduced down to less than 5 minutes. So we saved them 4 hours. Big deal, you may say. But of course, we're not saving them just 4 hours once. We're saving them 4 hours every single time they want to go down a new path of analysis. When you're in the world of research, you often, have a train of thought. You perform some kind of analysis. You get some results back, and they may be not what you expected. It may make you think, okay, let's go down a different path. So you're constantly opening up new pathways of discovery and accelerating that process. Another reason I wanted to talk about this slide really is that it kind of talks about the fact that, or it demonstrates the fact that big data is not just about volume of data. It's about sometimes time or speed and the ability to get information quickly. So in this example, it could have been that they were running quite a small amount of data. The point being that we were able to bring that data so much more closer to them, the answers so much closer to them, that you can have that conversation with your data that we spoke about earlier today. And that conversation with your data is something that the analysts in all sorts of industries, not just in pharmaceutical or research, they enjoy being able to ask a question and get an answer back, ask a question and get an answer back, so that your train of thought can move more quickly. If you're constantly having to wait to the following day to get an answer, you're not able to follow a train of thought around a particular idea, maybe a marketing campaign, etc. So I'll talk a bit about how Vertica works, and these are quite technical slides, but I think they do just demonstrate why it's a new technology. Okay, this isn't something that's been rehashed. It's absolutely brand new technology that was built from the ground up. And Vertica is a column store. It's a column store database, and it's the only one really on the market that actually can truly say that. So in the top half there, we have a column store, and the bottom we have a row store, which would be much more like your traditional Oracle, Sybase, Teradata type products. So if you ask a query of the data, saying select an average price with that symbol AAPL on that date, column store, Vertica, will just read the 3 columns that it needs to read, whereas a row store will read all the columns, because that's the way it was designed to do. So you imagine a lot of data sets may have 50, 100, 150 columns, and yet every time you ask a query, you may only be asking 3 columns worth. So straight away, the performance of Vertica and the speed, the way it can operate, is demonstrated by the fact that we simply just don't read that amount of data that's not required. Another mechanism we use to improve performance is compression. So within the columns themselves, you may get situations where the transaction date, for example, is a repeated field. An example there, the 5th of May. You then get customer IDs. Often these are just simply very long numbers, but they are very similar in nature. They go up with certain integers. Just click through. So for example there, we now store the 5th of May 2009 with a comma and saying 16 times. So that record has now been stored 16 times, but instead it's been only stored as one value. So we've compressed down just to that one value. You can imagine in some data sets, perhaps say telephone call records, that you might have 1 million transactions on one day. So we don't store the date 1 million times, we store it once. Again, massive compression of the data. Now we do this not just because it saves storage, because it does, it reduces storage dramatically, but it actually just speeds up the performance. And that's what Vertica is all about. It's all about achieving extreme high levels of performance. So the storage savings are just a bonus, and we see storage as a commodity situation. And there's the example. We store the main customer ID, and then you store just the level integer upwards to reference the individual. And the last display there is on trade. That's just like a Gzip, like a zipping of a file, just another example of what we do. That's just 3 examples, and we actually have about 15 different algorithms that we apply, constantly trying to make Vertica more performant. And just examples now of the factor of what we see in some of the data. So we tend to find that using compression technology within Vertica, you can reduce in clickstream data a factor of 10, in audit data a factor of 10, et cetera, et cetera. That's just examples that we found when we've been out there in the market providing our proof of concepts and testing to our customers. And lastly, you may be thinking, well, okay, that you're compressing data. How does that work when I actually come to analyze? Well, we can analyze the data whilst it's compressed. That's not a problem. And we only do actually decode right at the last moment for when you need to visualize the results. So there's no delay in decoding and decompressing. And we just call that last-minute materialization. And there's just a concept here which I won't go into too much more detail. So another example of this kind of column store speed and approach. If you have a set of data, this is an example of a college in America. You've got the student IDs, you've got the names, male, female, grades, score, etc. Now, obviously this would, in a situation with large data, be perhaps billions of rows. But for demonstration purposes, what we're saying with Vertica is that you can sort the information into male and female. And using the compression, you're going to remove the data that you don't particularly need. So you're storing the word female once, you're storing the word male once, and then freshman's only being stored once against the female. And now we're going to run a query which simply says, can you give me the average score, or the average grade A rather, where someone is female and she's in junior class. And what we're demonstrating here is that we get to that information in 4 very simple IOs. Again, just demonstrating that we're not looking at all of the data, we're able to focus very quickly onto the data that we absolutely need. All about speed and performance. If at any time you ask a different query, of course, you can find the right answer. You're not restricting at all. You're not doing any kind of pre-sorting or any kind of indexing. All the raw data is there for you to analyze. It simply enables you to target and focus very quickly down onto the right answer. And for the more technical of you in the audience, if an IO is around 5 milliseconds, that means that you can get to an operation in 20 milliseconds. And on existing databases, legacy databases, you're talking a considerable longer period of time to do that. This is an example of the architecture for Vertica. It's a massive parallel processing grid. Each node is a server with a local attached storage, and it's very modular in function. You can keep adding nodes into this environment as you need more and more data to analyze. It's so simple, there's no master nodes, there's no extra requirements. These nodes are standard x86 hardware, local attached storage, there's nothing proprietary here. These could be virtual machines, and in time these could be appliances that you may be able to purchase from HP. And this modular structure that we've created also implies high availability. So once you get to 3 node clusters, once you have at least 3 nodes in the environment, you have this automatic function that you can instigate into Vertica to allow for redundancy. So in that 3 node cluster environment there, the queries are actually spread so that if one node goes down, the other 2 can carry on and still operate. There will be a reduction in performance, but the queries will still get ran. Then, if you're a server, if you replace the node and you can let Vertica know, it then works out how to spread the workload back again, and you're back and running with the 3 nodes again. Vertica hasn't stopped, Vertica hasn't gone down, there's been no reason to stop your service at all or stop the queries. That also demonstrates as well that when you need to upgrade and add servers to the environment, you simply do just let Vertica know that you want to put an extra node in, and it will repopulate and redistribute across all the nodes, sharing the workload. So that's another very powerful feature, that you don't have to take Vertica down to do any of this kind of activity. In fact, the only time you need to to stop Vertica is when you want to do an upgrade, which is probably once a year. I won't dwell on this slide too much. It's just really an example of how it might fit into your environment. So the bottom example there is where Vertica would be installed, perhaps if it was a greenfield site. If you were starting a brand new project or business from the start, you could have Vertica simply taking information and going straight through to your visual applications. But in most environments where there's legacy systems, then Vertica can sit above the enterprise warehouse, like in the Obama use case that I mentioned earlier. So it can take all the feeds in from your existing databases and then point out to your visualization tools. Vertica uses all common industry standards, languages, SQL, and can absolutely comply with all of the major visualization technologies out there in the marketplace. So now that I've set that scene as to what Vertica can do, its power, its scale, how it can be seamlessly implemented into environments, and how powerful some of those organizations have released value from it, what does that mean for you guys? And these are just ideas that we come up with to say, well, if you have one view of your citizen, if you can simply put everything into one database, but take information from, say, police databases, schools, social care, and all the numerous systems that you guys have to manage, what does that mean for your fraud detection? What does that mean for your ability to provide a good quality care to individuals? Can you provide a faster, better service simply because the information can be made available in seconds and minutes rather than in hours? An example there I've put there is preventing a truant child that's found in a high street or something. How do you deal with that at the moment today? The chances are they get taken back to a police cell, they're stuck there for 2 or 3 hours, they try to work out where the child needs to go. You could provide information very quickly and know it's the correct information by knowing it's actually a foster home they should go to rather than their actual birth parents' home, for example. And it was mentioned in the Flanders video at the start, if you can empower businesses, imagine what you can do for your local economy if you can make it easier for a business to interact with your local government and to be able to start a new business or grow their existing business simply because it's a seamless process to be able to do that, something that actually encourages and stimulates that.